All right, electrical. So a brief system overview. We should all know by now that it's a 28-volt system. We've got one lead acid battery. No more NiCad batteries in any of our airplanes. Two generators, they're 250 amps each, and then our AC power is 115 and 26 volt. Two inverters, but we can only use one at a time. In the 90, we have the voltmeter bus select switch up there at the top. So pretty much any time you have any electrical faults, one of the first things the QRH will have you do is check the appropriate bus and see what actually is going on, and then it'll guide you from there. Most of the electrical controls are by the captain's left knee, so specifically the generator switches, the battery, or the master switch gang bar, the bus sense switch, and the gen tie switch. Most of the circuit breakers, however, are on the co-pilot's right side, so if you ever need any circuit breakers found, have them start looking. And then there's a few circuit breakers for the fuel system on the captain's side. Some features: the battery is always connected to the hot battery bus. Generator control units are what provide a constant voltage to and from them. We have a multi-bus system utilizing the left and right generator bus, center bus, the triple fed bus, and hot battery bus. We have our little Hall effect devices that will help detect high current. Some bus tie relays to help with automatic load shedding, current limiters to help protect the systems, and then multiple power sources for all the buses. So there's a pretty good diagram of the system, so anytime you're trying to figure out what's going on or thinking about what you're checking, I encourage everybody to kind of just remember that triangle, that you have the gen buses on the top corners with the center bus in the middle, the battery then going straight down, and the triple fed bus at the bottom. Just a few specific things about the center bus: that it's powered by the battery through the bus tie relay, and then powered by the generators through the generator buses and their respective bus tie relays. And do remember that the battery gets charged from the center bus. It can't come up through the triple fed bus to get charged, so if you would ever have a short and lose your center bus, your battery will no longer be getting charged. And or if you lose your center bus and your battery then dies, or even if your battery doesn't die and your center bus is out, the hydraulic power pack for the landing gear is also on the center bus. So if you ever lose the center bus, you're going to be pumping the gear down. Bus tie system protects us from excessive current flow. We've seen where they are on the diagram there between the generator bus and center buses, and then the battery bus tie between the battery and the center bus. And our bus sense switch we can use to reset the bus ties and or to test them. Spring loaded to the normal position. When you go to test, it momentarily opens them all, and reset will close them. Momentary activation only for both of those. The gen tie switch, manually closed, normal and open. Spring loaded to normal. Again, a momentary activation to manually close it, which will close them unless there's a fault. If there's a fault in the system, then it won't allow you to manually close them, which makes sense. If it's detecting something, it's not going to let you try to get yourself back in that situation. And that allows battery power to the gen buses, essentially all the buses when we close those. Bus isolation, we've talked about that a bit already. Sensors are bypassed during the cross generator start, and we had those couple current limiters, 250 amp ones, some pretty big ones there by the center bus, and then 360 amp ones down by the triple fed bus. With both generators offline, we'll get some automatic load shedding. The generator buses will drop offline, and the battery will power the triple fed, the center, and the hot battery bus. So there are our hot battery bus items. Fuel boost pumps are on there. That's why on the memory items for an engine failure prior to or an engine abort, takeoff abort prior to V1, if you see that you're going to go off the end of the runway, that it lists the boost pumps separately, even though you've turned off the gang bar, because those boost pumps are on the hot bus. So if you happen to go through some trees after that, we don't want fuel under pressure shooting out. The crossfeed crossfeed valve is on the hot battery bus, the battery relay, emergency panel lights. Like Steve talked earlier, the entrance lights and baggage lights, smart nav memory and a stereo, which we don't even have. I do bring up external power and recurrent just because we never use it. So if you guys ever do use it somewhere, I suggest just pull out the QRH and go through the steps in there. As a reminder, it's under the right wing. It's a 3-pronged AN plug. You get the annunciator when the external plug is connected. Not necessarily if any power is getting to you yet, just when something's plugged in there. And it'll flash if the external power switch is off and something's plugged in, or if the external voltage is too high or too low. So a quick little scenario here for you. You're flying along, and all of a sudden the autopilot goes off. I'm sorry, you're flying off, you took off into icing conditions. It's about 800 overcast, tops are about 15,000, and you realize you forgot to turn your auto ignition on, so you reach down to turn that on real quick, because you are getting some ice and it's pretty heavy moisture. And right after that, this happens. Your autopilot kicks off, the ESIS goes dark, you lose the Garmin, you lost COM2, NAV2, the ADF, and your transponder. And up here now we've got all sorts of annunciators. We have a left gen annunciator, a right gen, left and right engine anti-ice on, left and right engine anti-ice fail, left and right auto ignition, a left gen tie, and a right gen tie. So this is fun. So I'm actually basing this off of an incident that I heard about through secondhand. I haven't seen the actual report yet, but allegedly this is what happened. So now, what would you prioritize out of these enunciators here? Because this also creates a little bit of an additional challenge in a 90. Any ideas?
Well, we just talked about it, so I know.
Yeah, I was gonna say, Jesse might know this one too. If we're just trying to look at everything quickly, you probably think, well, we've lost both generators, right? So let's try to get that fixed. Well, if we pull out the 90 QRH, we either have this one, generator inoperative, left DC gen or right DC gen, or we have generator tie open or both gen ties. We don't have a dual generator failure QRH open. So we'll just pick one. Let's say we'll try this one. So it says reset and on, we try that, it doesn't reset. So now, okay, so that didn't help us. So we come down to this one, both gen ties, we try to manually close it. They don't close. So it says monitor load limiters. Okay, so now we're powered everything by the battery. Gen tie, we monitor it again. We try to reset, it doesn't reset. So we tried all this and nothing's working. So in this scenario, allegedly, the flight crew flew around for a while, tried to find VFR, couldn't find any. Eventually the battery died about 30 minutes later. So now they're flying around in IMC, no electrical power. Finally they're getting to the point of where fuel's becoming an issue. And they, one energy finally sees a hole in some clouds. He pops through the clouds as he's coming down through there. One of the engine quits from fuel starvation. They land in a field.
Oh my God.
Everybody's okay. But the big key for this one, when you're flying along, are these two little lights here. The left gen the left and right auto ignition lights are on. So if we would have been in a 200, the first thing that their dual generator failure says, note, ensure that the ignition and start switches are selected off. Otherwise, it will not be possible to reset the generator. The ignition and start switches feel exactly the same as the auto ignition switches do. So what they think was happening was he got in a hurry. He was fairly new, reached down, thought he had the auto ignition and turned those starters on. Gave himself a dual generator failure, and obviously you cannot get the generators online with those switches on. Tried to go through the QRH, didn't help him a whole lot. Didn't see that the auto ignition lights were on and didn't connect those dots there. And that's the end result. So I just like to bring that up to everybody because the QRH somewhat does set you up for failure because it doesn't have a specific one for that scenario. That'll make sense. That's a fun one just to talk about. Did you hear about that one, Jesse?
I don't think I've ever actually heard of that.
Yeah.
We do it in the sim,
Yeah.
or you
Yeah.
can see it in the sim every once in a while.
Yeah,
but-
it's pretty entertaining. In the
Oh
sim.
yeah, it's great.
All right, quiz time. What voltage do the generators provide? Voltage. That's right. D, 28 volts.
That's
Question 2, what is the function of the bus sense switch? That's correct. C, both A and B. Reset the bus ties and test bus prediction from excessive high current. Number 3, under normal conditions in flight, which of these are true? Well, you guys are great. You're correct. All of the following. The GCUs provide constant voltage, triple and center fed buses are powered to the generators, and the center bus powers battery charger. Question 4, which bus must be powered in order to charge the battery? Incorrect, Jesse. It's the center bus.
Oh,
Center
thanks.
bus,
I
not
got
the triple
it.
fed bus.
so close.
And the last question, if both generators drop offline, what buses will the battery automatically power? Because we do have automatic load shedding in the 90. It is D, the hot battery bus, the triple fed, and the center bus.
100%.
Thank you.